In 2023, the super-powerful James Webb Space Telescope made a sensational discovery, and not just one. It detected 6 massive galaxies we didn't previously know about, and they're all incredibly large. One of them is estimated to contain around 100 billion stars, which is the same amount as in our Milky Way. However, this galaxy is increasing 20 times faster than ours and will soon reach the gargantuan size of several dozen Milky Ways. Can you imagine how extensive that is? I personally feel uneasy when I ponder over the fact that, by cosmic standards, our planet is incredibly tiny. It's especially uncomfortable to think that astronomers have already obtained an image of a planet that could hold several Jupiters. They've also managed to find a star that's several billion times larger than our Sun. But that's not all. In this video, I'll tell you which object is absolutely the most gigantic thing in space. When you look at the night sky, it seems almost two-dimensional from Earth. Although nowadays, even a child will tell you it's actually not. But it took astronomers thousands of years to figure out how to measure distance from Earth to the stars and create real three-dimensional maps showing the distribution of stars and galaxies in the universe. Now researchers can even calculate the size and mass of astoundingly distant celestial bodies. And when it comes to solar system objects, it's like a first-grade task for them. Over the past 50 years, many probes have been sent into space. When they fly past a planet, scientists can measure how its speed changes. It helps determine the planet's mass. And to calculate its size, astronomers use observational data obtained from NASA telescopes and space missions. This implies that, for example, the size of the solar system's main giant can be measured almost down to the centimeter range. Thus, they found out that Jupiter's diameter is 142,518.4 kilometers. That's 11 times that of Earth. If the gas giant were the size of a basketball, our Earth would be the size of a grape. Moreover, Jupiter is 2.5 times as massive as all the other planets combined. Due to its large mass, this gas giant has a stronger gravitational field, which, according to many scientists, even helped form the solar system. If, for some inexplicable reason, Jupiter shrank, all the planets would just scatter across space. It's like when children spin around holding hands. If one of them opens their hand, the others will start falling and bumping into each other. But in our case, the solar system and Jupiter wouldn't have ended up just having some bruises and lesions. The planets would crash into one another, destroying everything in their path. In a nutshell, the gas giant is so massive that astronomers often refer to giant exoplanets with high surface temperatures as hot Jupiters. One of those planets is called WASP-12b. It is also a gas giant, but twice as large as Jupiter. Scientists began to call it the pitch-black exoplanet after the Hubble Space Telescope discovered that WASP-12b reflects only 6% of the light hitting its surface. It makes the planet look as black as fresh asphalt. But that's not the only oddity of this gloomy celestial object. While our Earth spends an entire year to make a complete trip around the Sun, WASP-12b orbits its parent star in just 26 hours. That's because the planet is too close to its star. This proximity even changed its shape. The star's tidal forces distorted it from a ball into something like an egg. But soon, WASP-12b will no longer be included in the top of the most giant planets because its parent star will eventually engulf it. Yet even with all this, the pitch-black exoplanet is not the main record holder. The most massive planet scientists have ever discovered is HD 1546b, and it's almost 7 times the size of Jupiter. Some would say it's undeservedly included in this list because HD is not really a planet but a brown dwarf. But since it's difficult to consider them full-fledged stars, scientists decided we could put it on the list of the largest planets in the universe. Whereas the celestial bodies presented in this top compete in their size, some giant space objects can compete in the degree of their danger. The largest object in the solar system is certainly not Jupiter but the Sun. It's 10 times the size of Jupiter and 109 times the size of our Earth. But such dimensions of our main star can play a mean trick on us. According to scientific calculations, the Sun keeps expanding throughout its entire lifetime. When it reaches its maximum size and becomes a red giant, its outer layers will begin to consume the planets within Mars's orbit, including our Earth. But the universe has many stars much larger than our Sun and therefore more dangerous. For example, VY Canis Majoris, which is 1,420 times more massive than our star and about 270,000 times brighter. But the most interesting part is that this extremely large red hypergiant isn't that far away. I'll tell you more, it's right in our Milky Way, in the constellation Canis Major. If this star replaced our Sun, it would swallow up everything that lies even beyond Jupiter's orbit. VY Canis Majoris is so huge that when it explodes, its remnants will produce an incredibly massive black hole. It's really scary to imagine what will happen when Stephenson 2-18, the biggest star among all red supergiants, collapses. It's 2,150 times bigger than our Sun. Scientists have determined that this celestial body can fit a star the size of 10 billion suns. Moreover, its luminosity dramatically exceeds that of our star by 440,000 times. That means if it suddenly replaced our Sun, all the oceans and wildlife on Earth would be gone within moments. But it doesn't even need to be part of our solar system to destroy all living creatures on our planet. A massive explosion of Stephenson 2-18 and the subsequent emissions could damage the atmosphere of Earth even from a distance of 20,000 light-years. Among other things, it could destroy the ozone layer protecting us from harmful ultraviolet light. Yes, humans would survive, but most of the world's population would suffer from radiation-induced diseases. It's good to know that, unlike VY Canis Majoris, Stephenson 2-18 won't create a black hole after it dies. Otherwise, this hole would be absolutely enormous, and the number of other stars and planets it would devour is simply frightening. There are already lots of giant black holes in outer space. The biggest of them is called Phoenix A. Its estimated mass is 100 billion times the mass of our Sun. If you could move at the speed of light, you'd need 71 days and 14 hours to travel along its circumference. In comparison, during the same time and going at the same speed, you could circle Earth almost 462 million times along the equator. Furthermore, the bigger a black hole is, the stronger of a gravitational field it has. This potentially puts all nearby objects in even more danger. Scientists, however, insist that we shouldn't worry this time because Phoenix A is quite far away. We can only hope they aren't wrong. But actually, they once believed that cosmic nebulae posed no threat either. Nebulae are giant clouds of dust and gas in interstellar space. When you Google the word space and find pretty colorful pictures, what you see in the majority of them is nebulae. They indeed look stunning, but you probably have no idea how enormous they are. For example, the diameter of the Tarantula Nebula reaches 1,862 light-years. In this video, I've repeatedly mentioned this unit of length, but do you realize the distance it implies? 1 light-year equals 9,460,730,472,000 kilometers. Now try to imagine an object a few thousand times bigger than this, equipped with long shining strings that look like spider legs. But there's an even larger nebula that contains as many as 15 trillion stars. So far, this is the hugest nebula known to science, NGC 262 Halo Cloud. It stretches over more than 1 million light-years, which is 537 times more than the area occupied by the Tarantula Nebula. Astronomers previously considered nebulae nothing more than mesmerizing space clusters, but it later became obvious that this beauty can also be dangerous. If a star or planet lies close to an active source of ejections that form a nebula, such as a young star or a supernova, they can receive a higher dose of radiation. In this case, the surfaces of neighboring celestial bodies can get damaged or even destroyed. Nobody knows how many space objects fell victim to NGC 262. Perhaps there were habitable worlds, or even worse, inhabited ones. Astronomers have Hubble, James Webb, and other super-powerful space telescopes, but none of them has helped prove the existence of life on other planets. The main problem is that there are a lot more galaxies with amazing, extensive planetary systems than you could imagine. Modern science says that the number of galaxies in the universe exceeds 100 billion. Our Milky Way alone presumably harbors from several hundred billion to several trillion planets. The Milky Way is a colossal spiral, only 15,700 light-years in diameter. Right, it's much smaller than some of the nebulae, but despite this, it's quite big by the standards of galaxies. Just think about it, every single second, one new sun appears in the Milky Way. To fill an entire galaxy with stars, we'll need around 200 billion years, which is 14 times longer than our universe has existed. But nevertheless, our galaxy is nowhere close to its relatives. ESO 30617 is a hypergiant elliptical galaxy 1 million light-years in diameter. It's 9.5 times bigger than our Milky Way. Because of its powerful X-rays, ESO 30617 is the brightest member of the Abell 3571 galaxy cluster. This galaxy can be found in a vast sea of dark matter and hot gas. It's hopelessly alone there, but that's rather good news for us. There's a hypothesis that the galaxy is so big because it once gobbled up all the companions it could reach. It turns out we are lucky to live in the Milky Way, which doesn't neighbor any space cannibals like that. Besides, scientists struggle to even approximately identify the number of planets in a galaxy so tremendous in size. Isn't at least one of them inhabited? Well, I guess we shouldn't be upset that we've never met hypothetical residents of ESO 30617 and its planets. What if they are just as aggressive as their cannibal galaxy? Even though our Milky Way can't compete with such a titan, the Laniakea supercluster, which is home to our galaxy, can easily set a new size record. This is an immense family group of stellar systems that peacefully coexist and form one structure. The Laniakea supercluster extends over 520 million light-years, which makes it 295 times bigger than ESO 30617 and almost 5,000 times bigger than the Milky Way. It seems that there can't be anything more extensive than that. But what about nothing? I'm talking about the giant void. This is an extremely large space region with an underdensity of galaxies. It is situated in the constellation Boötes. Its diameter is estimated to be 1.3 billion light-years, which is 2.5 times greater than the Laniakea supercluster and 12,000 times greater than our galaxy. But before I name the largest object in the whole universe and leave you speechless, let's look at it in comparison with the smallest of the space giants and then move further to our absolute record holders. Our planet goes first. It's an outsider, and we need it here only to realize how teeny-tiny we look against other astronomical bodies. Jupiter goes next, followed by planets WASP 12b and HD 10005 for 6b. Then comes the Sun and stars VY Canis Majoris and Stephenson 2-18. Black hole Phoenix A is next in line, followed by the Tarantula Nebula and NGC 262 Halo Cloud. And only then there is the Laniakea supercluster and the giant void. And finally, here it is, the unbeatable titan of outer space, the Hercules Corona Borealis Great Wall. This is the biggest known structure, extending over 10 billion light-years. It's 8 times larger than the giant void, 95,000 times bigger than our galaxy, and almost 5.5 million times bigger than the Tarantula Nebula. If I try to calculate how much the Great Wall exceeds the dimensions of our planet, I'm afraid I'll go nuts much sooner than I will find the answer because I'll have to face the truth and admit how small we are. But actually, even the Great Wall isn't the limit in space terms. Some physicists become very skeptical when someone mentions a hypothesis about this biggest object in the world. They even think all attempts to study it can undermine public trust in science or perhaps even throw all achievements of fundamental physics into question. Despite this skepticism, most scientists eventually agreed that this thing isn't unique and there are lots of similar objects in outer space. I think you've already understood what I'm referring to, haven't you? These things are multiverse. The most groundbreaking inventions let us see only the objects located 46 billion light-years away from Earth. And even when we peek into these impossibly distant places, we can't see the edge of the universe. It turns out that if anything can be bigger, that would be a group of corresponding universes that our telescopes just can't detect. Scientists suggest multiverse could exist in parallel dimensions, like the Upside Down in Stranger Things. Haiying Deng, a cosmologist at Arizona State University, believes that the existence of other universes is predicted by the theory of cosmic inflation. In simple words, inflation is a very speedy expansion of space. According to NASA, right after the Big Bang, our universe expanded extremely quickly over a suspiciously short period of time. It ballooned from a little dense dot to the infinite space we see today. Heying says that inflation doesn't usually stop everywhere at the same time. Most likely, when this process ends in one region, it may continue in others. So when inflation ended in our universe, there could be remote areas where it carried on and is still not over today. Certain universes can even nip off pieces of larger worlds and keep them. What's more, due to eternal inflation, they all appear with their own laws of physics and sets of particles. Some scholars assume that every universe is a hypersphere that touches another hypersphere, and it repeats countless times. Curiously enough, the idea of the multiverse appeared before our era, thanks to a Greek philosopher named Anaximander. And despite a complete lack of evidence, modern cosmologists keep it in mind anyway. Nick Culling-Sandora, an affiliate research scientist at the Blue Marble Space Institute of Science, explained why scientists don't seem to lose interest in this controversial and somewhat fantastic concept. The point is that some aspects of our universe seem quite special and specific to sustain life. For example, the longevity of stars. The abundance of carbon and the availability of light for photosynthesis are key factors that support life. It's highly suspicious that so many details ended up so perfectly aligned in our universe and created favorable conditions for the emergence of life. It's very doubtful that this could happen on the first try. If there are indeed many different worlds, the same patterns will inevitably reoccur. Some researchers suggest that universes inside the multiverse are so alike that humanity exists in many other separate worlds in different variations. Assuming that the largest object out there, the multiverse, does exist, our lives remind me of a movie, Everything Everywhere All at Once star. Its main character has her copies in numerous alternate worlds, each copy popping up when she made a fateful mistake or some crucial decision. Long story short, the multiverse can be so tremendous in size that right now, at a mind-blowing distance, a duplicate copy of you might be watching the same video, or rather, an infinite number of your duplicates. One of them will probably close the laptop lid, saying, "What a bunch of crap, where's the unfollow button?" But another version of you will start digging deeper into the topic, get hired by NASA, and unravel all the mysteries of the multiverse. Which of the versions do you think you are?